This Atari 1030XE was donated to the channel by fellow YouTuber Ctrl-Alt-Rees. Let's open up the box and see what we have. I do like a set of functional vintage flaps. And a shake of the accessory box reveals that inside there's absolutely bugger all. But any collector will tell you that the accessory box is harder to come by than the contents themselves, so I'm taking that as a win. Next out of the box is the 1030XE computer. It's a bit grotty, quite yellow, but it is straddled by a pair of pretty original polys. Like the accessories box, it's really difficult to find these in this great condition, so I'm very grateful to have my hands on them. It's a bit yellow, it's very grimy, and if I recall correctly at the time that Rees handed it over, he told me that it was incredibly broken. So this is going to be the start of my learning experience with this machine. And I'm going to be totally honest with you here, I have no idea what I'm doing. Despite the grit, the grot and the grime, the protective strip is still on the nameplate. Look at that. The urge to peel it off is massively strong. Maybe another time. So we're going to start our learning journey, and we're going to start it right now.
Mark fixes stuff.
This channel is sponsored by PCBWay, and they don't just do PCBs. If you want professional 3D printing, just upload your models, pick from a variety of materials and colours, and you're on your PCBWay. Thanks to Elaine and the PCBWay team for supporting Mark Fixes Stuff. Just a note to say that the power supply is known, tested and working on a working machine. Likewise, the video cable from Retro Computer Shack is also working. Often, when I get a retro machine, I'll do some preliminary checks before I even power it on. But I know this has been powered on before, almost certainly more than once, so the risk of me introducing any new errors is pretty low. Shout out here to Retro Computer Shack, who make awesome video cables. That's not sponsored, it's just a fact. I'll pop the lights off so that you can see better when we power on the machine. And nothing. At this point you'd expect to see a blue screen with a cursor appearing, but this machine isn't doing anything. So there's obviously a problem here. This Super Salt diagnostic cartridge that we made in a previous video will work on the XE range of machines. It should swap out the internal ROM and bypass the RAM inside the computer. But alas, again, nothing. This means that there's something critically wrong with the computer, so it can't even boot the cartridge. My immediate guess is the RAM. These have been known to use terrible RAM which dies over time. But one thing I have noticed is that the LED that should glow red when we power on the computer doesn't power on at all. And it's not that it's dimly lit, it's just not turning on at all. This leads me to wonder if there might be something wrong with the RAM chips in the machine. The power comes in here, the 5 volts needs to get to the LED, and it goes via the ribbon cable which is plugged in, I think over here. If the RAM goes short, they turn into tiny little silicone heaters, and it stops the power getting any further. But I've got something that we can use to try and detect if the RAM's getting hot. Well, hotter than usual. This is the TCView TC002. The TC stands for thermal camera, and the 002, I don't know, probably stands for some kind of Bond villain. TopDon were kind enough to send me this for free, and I know my viewers don't mind if I slip a cheeky one in sometimes. It's actually quite a nice looking box. The outer part of the package is one of those sleeves which seems to be de rigueur these days. Luckily this one comes off with a minimum of effort. Some of the specs and an explanation on how these things work. It's a 256x192 high-res IR camera that shows temperature changes in real time for your Apple device. You can set an alarm if a temperature goes over a certain threshold in the software, and the testable temperature range is minus 20 degrees centigrade to a whopping 550 degrees centigrade. It has customizable imaging optimization. An IR camera doesn't actually show you pictures, just emitted IR signatures, so you can choose any colour you like to be those. I tend to go for black and white myself, it's less dramatic. There's a nice little case inside the box, and there's also this handy dandy instructions leaflet. You know that I really love an instruction leaflet. Let's open up the zip case and see what we're dealing with. And now I've seen it with my eyes, it's a lot bigger than I was expecting. My past experiences were with a smaller unit. There's a rather lovely extension cable here. It's quite unusual to see a lightning extension cable. If you needed instructions for this, well, here they are. I don't really know why this is in the package. Perhaps so you can use the unit freehand. Yeah, that makes sense, I suppose. It's really nicely built actually. Kudos on the build quality. Okay, I'll admit it, I had a look at the instructions. And I have to say, they are quite a lot better than the sort of instructions we're used to with devices like this. The language is all correct and easy to understand, and on the reverse side we're treated with, well, absolutely nothing. Which equals less instructions to read, and a big win in my book. Let's get this all out of the way. The software is easy to find on App Store, top infrared. It's only got 3 stars, so I'm a bit wary. But having said that, it's easy enough to operate. The software prompts you to insert your unit, and then after jabbing away at a few buttons, you're into the software itself, and you can see just how hot stuff I am. I don't think I'll ever get tired of leaving heat trails on surfaces. It's boiling hot in here today, and the filming lights are on, so we will get some slightly abnormal temperature readings. You can ignore that in the real world. Talking of the real world, let's get back to our 1030XE. To open this machine up, there's only 4 screws. I'm going to go manual and use a manual screwdriver today, just so you can see how old school I really am. Usually I'd be using my handheld microelectric screwdriver, but in the process of packing for downsizing, I'm not quite sure where I've put it. With the 4 screws out, we can flip the machine back over onto its bottom and lift off the top shell. It is a bit grim inside, but not as grim as I was expecting. We can clearly see that LED that wasn't lighting. It's fairly unusual for an LED to go, and the power it requires should be coming from a ribbon cable over here. And there is said ribbon cable. It looks like it's in okay condition. Sometimes these crack or split. Being a bit of a newbie, I'm not sure if this has done either. But let's take it out gently anyway. I've got quite a lot of experience of doing this with other retro computers, but you do have to be gentle. And just like that, the keyboard is removed. Let's set it aside for later. The next thing we have to do is remove the top of the shielding, and it's held on by these small twist tabs. These are really easy to take off. All we have to do is straighten these small lugs. I'm starting to wonder if the person who had this machine before was a big Jeff Minter fan. I mean, it's Atari and Jeff Minter is synonymous with that brand. I'm a fan of Jeff Minter's work as well, in particular his ruminant focus titles. There was Llamatron, there was Attack of the Mutant Camels, and he even called his software company Llama Soft. Why am I mentioning this, you might wonder? Well, the eagle-eyed amongst you might have seen, inside this machine, there's quite a lot of hair. And down by the keyboard connector I found a further couple of hairy balls. If that's a cat, I don't want to meet it. Honestly, this hair is literally everywhere. It's huge. With our tabs liberated, we can lift the shielding off of the mainboard and let the dog see the rabbit, or the llama, whatever is applicable here. The RAM is situated on the left-hand side of the computer. This mainboard is exactly the same as the 65XE, with just some additional components and of course more RAM. If one of the RAM chips is pulling the 5 volts down, it won't be supplied to the keyboard connector and therefore the LED. So I think what we'll do is we'll turn on the machine, then watch with our thermal camera to see if any of the RAM gets stupidly hot. If it does, it could be where all the 5 volts are going. I've touched one of these in the past when they're hot, and the resulting scar makes me not keen to do that again. Failed RAM doesn't always get hot, but it shouldn't be pulling the voltage down if it's cold. Now, thermal cameras don't need light. Instead, they show infrared emissions from a heat source. That's why you can see heat being reflected off the shiny parts of the motherboard. It's actually a reflection of the IR from my hand, and not actual heat. IR tracking is nothing new. Police helicopters use it, and Maverick used it in Top Gun. Ah, the 80s. Let's turn this machine on. And from Top Gun to TopDon, immediately we get some very bad news from the TC002. The RAM chips in this Atari are glowing much hotter than they should. In fact, you can see the one underneath the red circle is going up and up. It's gone faulty and is dragging all of the energy into itself, creating heat. It's up to 80 degrees already. I'm glad my finger isn't on that one. But a bigger problem is that 8 of the other chips are also getting hotter than they should. That amount of RAM chips going bad at once is unlikely, and it suggests that something terrible has happened to this computer. Possibly the wrong power supply being used, which is bad news not just for the RAM, but also some of the custom chips in the computer. But I'm not giving up yet. With those RAM chips installed, we have absolutely zero chance of troubleshooting the machine. My friend Simon Green, has lent me this RAM tester. It's very kind of him. He's also lent me some RAM chips because I'm out of stock. So I think what we'll do is we'll take the main board out and then we'll replace the RAM chips in the computer. You never know, it might spring to life. I mean, it won't, but you never know. Good news, by the way, screwing fans. These screws are completely different to the others, so if you get them mixed up, you'll mess up your case. Trying not to inhale any dust bunnies, we remove the board from the case. We'll put the case aside for later. Now this is a lot of RAM. Desoldering this is going to take a long time. Luckily, I have a desoldering station. I wouldn't suggest trying to do this manually. I'm setting the desoldering station to 360 degrees Celsius. And to start with, we'll remove this chip. This was the one that got hottest when we were looking at it with the thermal camera. Then we can put it into the chip tester. Today, I'm going to use a flux paste. I like to use a clean paintbrush for this. The nice thing about flux is not only does it clean any surface contaminants off the pins, but because of its nature it kind of creates a nice interface between the tip of your desoldering gun and the joint itself. I'll make my usual caveat here. I'm not pushing down on the board and scraping it. I'm just gently wiggling the leg around in the molten solder. This helps to get all the solder out of the hole. You'll be relieved to know I'm not going to film every single solder joint. That might be excessive even for a Mark Fixes Stuff video. And I have to tell you that nothing reveals the joy of desoldering station more than this. When the chip you're desoldering just drops out of the PCB. And to be honest, most of them are very easy to remove. As promised, we'll test this chip. I know it's going to fail. Here's Simon's tester. He didn't make it, he bought it off of eBay. This is a 1x64 kilobit chip, and as such it needs to go into the right hand socket. This is important because trying to test it in the wrong socket will kill the chip. Don't do that. Let's pop off the lights. The 4 LED colours are a signal that the tester is ready to rock and roll. Pressing the button starts the test, and it immediately goes red. A sure sign that the chip is dead. Considering it was hot enough to boil water earlier, that's kinda shicer Sherlock. Simon Green was kind enough to let me use his parts for this project. 1x64 kilobit RAM is often marked up with lots of different part numbers from different manufacturers, but most of them are cross-compatible. Let's test one that actually works. I hope. Pressing the button to start a new test, we can see the LEDs start flashing. So what's happening here is it's writing sequences to the chip and then reading them back. There's a whole technical spiel on how it does it and what it's doing exactly, which I've forgotten. However, the easy thing to remember is that these lights go flashy, 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 and at the end, if you get green, it's good news. So this is a pass. And whilst I distracted you with that, I've gone and desoldered all the legs of the chips. And of course, I'm trying to look all cool, but I've got the manual dexterity of a drunken cocker spaniel as soon as the camera's turned on. Removing the chips is dead easy. There's no trickery here, I've just desoldered the legs. It's still a long process, but a lot easier than the manual route. Sometimes you do get a bit of minor resistance as you try to lever the chips out, and often this can be gently overcome. It is important, however, not to use too much force, because you can easily take a track or a pad out of the board. For example, this chip won't budge. Looking on the underside of the board, I realise I missed one of the legs. If I'd tried to lever that out, we would have had a disaster on our hands. After desoldering the final leg, the chip comes out easily. In reality, this job took about 40 minutes. Just another note here, I will test every piece of RAM before I put it into the board. I did a couple of tests before I turned the camera on, and 3 pieces of the RAM out of Simon's parts actually failed the tester. So I'm quite wary now. Usually if the test starts, then it's a fair bet that it's going to be okay. But it only takes 20 seconds. Of course, I won't be soldering the RAM straight into the board. That would be incredibly stupid, and as prone as I am to doing incredibly stupid things, not today, Satan. By the way, it's not what it looks like. These aren't marks on the underside of the board, they're actually flux, and I'm only using the very tip of my tool to bend those leads over, just in case you thought I was scratching the underside of the PCB. Soldering iron set to 330 degrees Celsius, yes, that's the magic number, and we'll grab some leaded solder. It's always important to keep your tools sparkling clean. I like to rub the tip of mine in some wire wool. And unless you like lead poisoning, throw on your fume extractor. Soldering sockets is a bit different to soldering components. Essentially, you only have a small piece of metal which is held in place by a plastic body. Of course, if you overheat the leg, it can start to melt the shell of the socket, and you don't want that. I didn't have enough sockets, so I ended up raiding Simon's box again. And apologies to any viewers who are going, "Good grief, those are some cheap sockets." Because they really are. They are the lowest of the low. But sometimes you've just got to use what you've got in your hand. We've got to get the job done at the end of the day. The technique for soldering socket pins is the same as any component. You need to heat the pin and the leg at the same time. Something that I'm failing to do when I look back at the footage. But in my defense, it's hard to do this around the camera. And when you've got a small thermal mass of a pin in a socket, it's not quite so critical. The solder flows around the pin anyway and transfers the heat that way. It's just not the most efficient form of thermal conductivity. You'll be pleased to know that I'm not going to film soldering every socket into the board. As I place the sockets into the board, I'm thinking about what the possible problems could be. And I'm afraid the more sockets that I put in, the more that I'm thinking that the problem isn't going to be just the RAM. Even with the worst brand of RAM, MT RAM by the way, they don't usually fail in huge batches like we've seen. So I'm thinking something bad has happened. Like we said before, perhaps mispowering of the board. These sockets are okay for now, but to be honest, I'll probably replace them later with higher quality parts. Speaking of parts, here's Simon's parts. We're going to pop them into the sockets. And with all the sockets populated with tested RAM, it's time for the moment of truth. But let's delay that for just a second, and let's look at the RAM that came out of the machine. I've tested all 16 of these, and the results are in. On the thermal camera we could see 9 chips that were abnormally hot. These 4 chips passed the test, leaving a stonking 12 chips that failed. Absolutely catastrophic. And with that in mind, we power on the machine. And nothing. A sad result, but not one that was unexpected. The TV knows that there's something there, but what is there doesn't do anything. So I'm left thinking it might be one of these custom chips. Our thermal camera shows an overly dramatic looking image, but that just means that these chips are slightly above room temperature. For hits and wiggles, I decided to try a cartridge. And I did get something odd, which is a kind of a scrambled image. So maybe there's hope after all. So where next? Well, this video is already getting too long, so maybe in a future video we'll use Sam's computer facts. This is a really excellent resource from back in the day. I hate that term back in the day, I don't know why I say it. Anyway, there's lots of circuit diagrams and places where you can pop your oscilloscope to see if chips are functioning correctly. I don't think it's going to be the capacitors, maybe the memory logic, but on the bright side we wouldn't have been able to do any testing with the thermonuclear RAM still installed. So is this an epic fail? I'm not sure. One of the big problems we might have is I don't have any of these custom chips as spares. Massive thanks to my amazing patrons appearing on the screen right now. Patrons really do keep the channel running, especially at the moment whilst I'm downsizing the channel. Patrons are practically blessed with ad-free early access to all my videos. There's a Patron exclusive vlog, although that can be a bit infrequent at times. There's also a Patreon Discord channel in my Discord server where patrons can noise me up. Oh look, there's Rees in the list. Thanks for the computer, Rees. Patrons also get the ability to dance the lambada. This might not be true. Big thanks to TopDon for the TC002 thermal camera, and thanks to Simon the Green for allowing me to rummage through his drawers and use his parts. Right, that's about it. Go and watch one of these other videos please, I need the ad revenue. Go on. Why are you still here? Go on.